Alright, this is Mr. Butterfield here as the notes pre-calculus, section 19.4. There's not a whole lot to it. There's got a little bit more review to this that I might actually skip over and just focus on the newer parts and the lessons. Let's just see how this goes for a recording. Section 19.4, you put the date. I'm doing this on Thursday the 8th. Whatever your date is when you're looking at this, put it down. So first of all, we're going to do a little bit of review as we go along. Graph first. So graph, the main idea today is going to be about restrictions. Restrictions on domain. And there's only a couple cases of where that happens. Restrictions on the domain. I can identify whether the inverse function is a function. So like the function passes the vertical line test, and then the inverse function also passes the vertical line test. And then say the domain and range of function and its inverse. Sometimes there are, sometimes there's not any restrictions. Any restrictions so that they're both functions of x. They both pass the vertical line test. That's what we're getting at here. All right, first things first. When you see that it's x squared, all right, this one is nice because it lets you know what the vertex is and stuff. But anytime we see that the x is being squared, we know we're dealing with the parabola. And actually, I did that wrong. If it's got a negative in front, it actually turns your parabola upside down. So when we graph this, what we're going to get is an upside down parabola. The vertex is at, solve for x, that would equal 3. And then just use that number of 4. The 2, because it's negative, turns it upside down. Because it's not a 1, it's not the normal pattern of numbers. So I go to 3, 4, 3, 1, 2, 3, 4. And it's going to be a parabola upside down. But how do I get other points? You could just pick numbers to plug in 4, plug in 5, plug in 2, 1, 0, make a table. But usually it's odd numbers. Parabolas go in odd numbers. So it would be like, well, usually it's up 1 over 1, but because it's upside down, you would say down 1 over 1, down 3 over 1, down 5 over 1. The 2 in front just multiplies the pattern. So instead it would go down 2 over 1, down 2 over 1, 1 times negative 2. And then instead of down 3 for the next step, you go 3 times negative 2, it would go down 6. 1, 2, 3, 4, 5, 6, and over 1. Always over 1. Now you got enough points. And the 2, what it does is actually make it skinnier than the normal U shape. You can answer these questions. What's the domain? From all the way to the left, all the way to the right, all the numbers will show up on the graph. So that's all actually negative here, positive here, lowest to highest. All right, it's another way of saying all real numbers. The range, the lowest is down here and the highest is at the top this time. So don't be fooled and start at the vertex on this one. The lowest y's are down here, all the way down here, coming all the way up, and the highest y number is 4 included. 4 included. Is it a function? Yes. Passes the vertical line test, VLT. If I draw a vertical line, it can only hit the graph one time. Any vertical line I draw can only hit the graph one time. All right, now what they're asking us to do is, hey, find the inverse function of the same one. Inverse. Switch x and y. Negative 2. All right, so I subtract 4. Get this. All right, then I divide by a negative 2. I want to divide each one individually, so it would be negative 1/2 x. This divides, becomes plus 2. Now I want to square root both sides. This will need a plus minus in front of it. All right, so the squared part would be gone. The last step would be add 3. I'm running out of room here. So the inverse will be this 3 in front plus minus square root negative 1/2 x plus 2. Ugly, 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 ugly. So if I ask you to graph that, I think we would all freak out like, oh my God, I got to graph that thing? That thing looks like a hot mess. But remember, if you have the original graph, all you got to do is flip around the points. The question to you is, like, do you know what direction it would point in? And my first period class that I did this with, they saw me sort of mentally make the mistake. I'm like, yeah, it's going to be a parabola. It's going to be going sideways. Like over here, it's going to be going sideways. But remember, this one was turned upside down. So it actually opens up. When a parabola is going up, a U shape going up, it's going to flip over like this. When it's upside down, it's going to flip over and go open up the other way. When I reverse these points, this is at 3, 4, so this one's going to be at 4, 3. This is at 2, 2. This stays 2, 2. This is at 4, 2. This is going to be at 2, 4. And now you can kind of see what I'm talking about. It's going to be opening up, going to the left. This one is at 5, negative 4. This will be at negative 4 and 5. Let me get this right. And this one is at 1 comma negative 4, so this will be at negative 4, 3, 4, negative 4 comma 1. All right, what's the domain for this function? Well, I can pick any number to the left. So it goes from negative infinity, but it doesn't go all the way to the right. It stops when you get to the number 4. What about the range for this? Well, I know it may not look like it the way I drew it. It was so skinny, but this upper arc will end up going up, and this lower one will end up going down, so that U shape will get wider as it goes to the left. It is all real numbers. All the y's will show up. Notice that the domain here is the range here, and the range here is the domain here. They just sort of flip-flop. Is this a function, though? What they mean is it a function of x, and this is going to be important. No, it's not. Doesn't pass the vertical line test. Any vertical lines that I draw, is going to hit the graph twice. And what that means is if I put in a number like the number 2, I can get 2 outputs. It's got to be that each input you put in, like when I put in a 2 over here, there's only one answer. Oh, I'm sorry, let me get on screen and do that again. When I put in a 2 over here, there's only one answer. When I put in a 3, there's only one answer. Put in a 4, there's only one answer. Not true over here. It's true for the number 4, but then that's really it. If I put in the number 1, there's 2 answers. If I put in 0, there's 2 answers. All right, I don't know what they are right now, but it's going to hit it twice. That's why it doesn't pass. So this is all review up to this point. This page has really got the only so-called new stuff to it, the new stuff. What is an invertible function when f of x and the inverse are functions? In other words, the original is a function of x, and then the inverse is also a function of x. So basically, certain graphs are not going to be what they call invertible. Take this one, for example. Anytime we get a parabola shape, we now know, hey, when we do the inverses, it's going to be a parabola this way, or if it was an upside-down parabola we just showed, it would go the other way. But the inverses are not. So the answer is no. All right, it's not. It's going to end up looking like this, or it reflects over this line. All right, so it would be a sideways parabola. So consider how you can restrict the domain for the original to make it. We want to make it invertible by using what's known as a restriction. This is the new part. For these kind of graphs, what we're going to do is say, hey, we're only going to count this graph, either one half of it or the other half of it, so that when we flip it, all right, so that when we do the inverse, then it's going to be a function of x. And basically for this, we're going to use the vertex. This vertex is at 2, -1. We're either, let me cover this up. We're either going to use this half, and then we'll say anything below the number 2, or we're going to use this half, anything past the number 2 going this way. One or the other. How do we do that? You would say the domain. If you want to use I almost said -2. Before 2, including 2, then you would write that as, hey, we're going to go from -infinity up to the number 2. Or if we want the domain to be after it, then the lowest number from 2 to infinity, it would look like this. Basically, you have to restrict it one way or the other. Use this half of the parabola or that half, and then what you have is what's known as an invertible function. And if I stumble on the word invertible, it's because in years past I never used the word invertible. We use some other terminology, so that one's a little bit new to me. Invertible just means that it's a function one way, and then the inverse is also a function. This also relies on you guys sort of remembering, like, hey, just looking at the equation, do I know what the graph looks like? And I know when I taught it to my first class, it's been a struggle. Both classes, really, it's been a struggle. So consider h of x is equal to 4x minus 7. Is this invertible? Well, if it's just x to the first power, you have to think for a moment, like, what does that graph look like? And if it's x to the first power, and this is a positive slope, what you have is just a straight line. Okay, it's not graph well or anything like that, but is that invertible? Like, if you're reflected over that dotted line, all right? One way you can tell is like, hey, does it pass a vertical line test? Oh, absolutely, that's a function. Would it also pass a horizontal line test? That would tell me if the inverse is a function. And the answer is it would pass both. So the answer is yes. So do I need no need for restrictions. All right, this is where the notes are a little bit funky here. There's no need for restrictions here. The original and the inverse are both going to be functions. So is it invertible? Yes, that means there's no need for a restriction. Okay, so there's no restrictions. Can I put the domain down? Yeah, it's basically, it's all real numbers. So it would be like from negative infinity to positive infinity. What's the range? From negative infinity. So the inverse would be the same. Now technically, the range here is the domain here. Really, all four of these are going to say the same thing. All real numbers. All right, so rule number one. If they give me a straight line graph, then it's going to be, it's invertible. This is a square root graph, so some kids had trouble picturing what this looks like. Notice it doesn't say plus minus out in front. So a square root graph has this kind of a shape. It starts at a certain point and just goes up. If it said negative in front, it would be the lower part. It's a parabola on its side is what it basically is. This plus 1 in here means it's shifted from 0, 0. It shifted 1 from 0, 0. It shifted 1 to the left. And so from here, it just has this little hook. And as it goes to the right, it will go up and up and up, but at a pretty slow rate. Is that invertible? Well, you can picture what the inverse looks like. That might be tough for some of you. Or you could say, does it pass the vertical line test? Yeah. Would it pass the horizontal line test? It may not look like it here, but this goes up as it goes to the right, so the answer is yes. Horizontal lines would only hit it one time. So the answer is yes. So there's no restrictions when the answer is yes. There's no restrictions. What's the domain here? So the domain is from negative 1 going up. So from negative 1 to infinity. That's all the x numbers. What's the range? Now you gotta look at it up and down. The lowest one is 0. All right, it starts on the 0 line and goes up. Now, I didn't even draw the inverse. We didn't draw the inverse. But all you got to do is take your domain and range and flip-flop them. The domain here becomes the range here. And the range here becomes the domain here. If you are wondering, hey, what does the inverse look like? That one started at -1 and went this way. Remember, it reflects over this line. So this one would, that's -1, 0, so 0, -1. And then it would go up like that. That would be the reflection. All right, so this is the main idea. Do we need restrictions? So the next one they do, and there was a lot of like, I don't remember this. This shape is a V shape, and it shifts the same way as like parabolas. This x plus 2 on the inside means it shifts 2 to the left. 2 to the left. So the graph would look like 1, 2, boom, and going up. The inverse of that, all right, the inverse of that, well, that's at 2, 0. So this will be at 0. Well, I'm sorry, that's at -2. That's at -2, 0. So this would be at 0, -2. And that would be a V going this way. So is it invertible? This would pass the vertical line test. It would not pass a horizontal line test. That lets you know this would not pass a VLT. So the answer is no. Needs restrictions if we're going to make it invertible function. Okay? So this one needs a restriction. Needs a restriction. We're going to count either the left half of the V or the right half of the V, and -2 is going to be sort of like our dividing line. All right, let's say I'm going to choose the right half, the positive half. Then I want it to go only count from -2 and up. My range is still going to be from 0 and up. So in other words, for the x numbers, I'm not using all real numbers, -infinity to +infinity. I'm taking away this half of it. I'm taking away that half and only counting this half, so that when I do a reflection of it, okay, when I do the reflection, I only have 1/2 of it reflected over. So only this part would show up. What's the domain? Well, remember the domain of the inverse would be the range from the first one. So it would start at 0 and go up. And the domain from this one becomes the range for this one, the lowest number, -2, and it would go up from there. So it's just learning how to do some restrictions on this stuff in case, you know, they ask you to make it invertible. This is the key word. If they ask for it to be invertible, then hey, I got to put a restriction on it. Consider this last one. Now it's hard to tell what the vertex is. Well, you can tell what the vertex is when they give it to you, right? So this goes back to like our first unit when we did circles. There was a little bit of a review of this, but what you need to do is called completing the square. And when I show you this, then some of you guys go, oh yeah, I remember doing this. So we're going to make it so it's a parentheses squared and then plus or minus a number, so that it looks like this, and then it's easy to go, oh, the vertex is going to be 3, it's going to be 4. We're going to make it look like this form. All right, so let me go back. So I got x squared minus 6x plus 5. You move the 5 over. Oh, first of all, is it invertible? Because it's a parabola shape and it's right side up, because the one in front is right side up, the answer is no. So it's going to need restrictions. It's going to need restrictions here. All right? So what I'm doing is finding the vertex so that I can make the restrictions. X squared minus 6x plus blank minus blank plus 5. So hopefully I'm giving you a moment, like, does that look familiar? Do you remember that? Do you remember that? You take half the middle, and then you square it, and that fills in the blanks. So half of that is -3. Square -3, you get +9. So since I'm adding in 9, I take away 9. These three numbers here, they factor. What two things multiply to be 9, but they add together to be -6? It's x minus 3 times another x minus 3, but we don't write it like that. We write it like x minus 3 squared, and then -9 plus 5 is -4. So this, in its factored form, is x minus 3 squared minus 4. Technically, there's a 1 in front. That means the parabola, do a rough sketch here, would be at, the vertex would be at 3 and then 4 and going up. And we just want one side or the other side to count. We don't want both. We want to split this down the middle and use either this half or this half. I'm going to choose the left half this time. So this is the part I'm going to get rid of. So I'm going to restrict it. I'm going to use -infinity up to this number. -infinity up to this number, which was 3. So -infinity up to +3. And that domain would end up being the range. I can put that in right now. All right, and since this is 3 over and 4 up, whether I had the full parabola or just this half parabola now, what is the range of it? The range, the lowest number is a 4, and it goes to infinity. That means when I do the inverse, that will be the domain of it. Like it would flip over. So that vertex was at 3, 4. This one would be at 4, 3, and then it would be an upside down. Like it would look like a square root graph when it's flipped over. All right, give you a moment. Write all that down. Absorb the beauty of the inverses and the restrictions. All right, now this is where I'm going to kind of stray from the rest of it. All of this is review. Next week is review. This is our last lesson before we have a test, and I'm going to sort of do more practice and stuff like that. This is all practice. There's a lot of practice in your homework on how to do this. I'll do one. I did one with my other class, so I'll do it here. Switch x and y, and then solve for y. So that's a 3. All right, so I'm going to add 3 over. I get x plus 3 equals the cubed root of y. And how do I get rid of a cubed root? A cube both sides. So that gets rid of it here, and that'll be just y by itself. So I can call it h inverse equals, I'm going to bring it over to this side, so it's going to say parentheses x plus 3 cubed. And remember, you can't distribute that. And I had a kid ask in class, they're like, well, should we multiply it out? In this case, I would say no. That would mean you'd have to go x plus 3 times x plus 3. Whatever you get, multiply by another x plus 3. You're going to get a whole lot of parts to it. So they definitely didn't leave us enough space for it. We're going to leave this as is right here, and that's good. So there's a bunch of review questions, but nothing that goes with like the restrictions until we get to the very, very end. So let me do another practice one with you. So the rest is reviews. If you want to practice them, I'm probably going to come back and talk about them and use them next week. The last 2 problems, those are the restrictions kind of problems. The only issue I have is same as last example problem. That's the same problem we just did. X squared minus 6x plus 5. So I'm going to skip this one and just do this one and end it here. So x squared plus 8x plus 15. I know it's a parabola. I know it's going up. I know it's not invertible as is. Because it's not invertible, what I'm going to do is put a restrictions. I don't need a restriction down the range. That's a typo. I don't need a restriction on the range. I need a restriction on the domain. Restriction on the domain. So we're going to do completing the square so that I can find out what the vertex is. So x squared plus 8x, am I on screen? Let me move that. Plus blank minus blank, and then plus 15. What fills in the blank? You do half the middle number. Half of that number is 4, and then square it, and that fills it in. So half that number is 4. 4 squared is 16. Also take away 16. When you group the first 3, what you're going to get is like a repeat of the factors. What two numbers multiply to be 16, but when you add them together is 8. And it would be plus 4 and plus 4. So we're going to write it as x plus 4 squared. Don't write them separate. And then negative 16 plus 15 is a negative 1. Why do we do all that? It was really just to find what the vertex is so I can cut it off left and right. So that answer would be negative 4, and just bring that number down. It's going to be at negative 4, negative 1. So picture that. If we were graphing it, it would be at negative 4, negative 1, right side up. We want to split it in half. I'm going to use the right side this time. I'm going to get rid of this side so that it's invertible. This would pass a vertical line test, but as is would not pass the horizontal. So because it doesn't pass the horizontal line test, the inverse is not a function until I restrict it. Now, I'm only going to count this half of it. So that means from negative 4 going up. So I'm going to go from negative 4 to infinity. That'll end up being the range when I do my inverse. What's the range of this original graph? Well, the lowest is a negative 1. All right, just below, there's my x-axis. So just below the x-axis, negative 1, and then going up. And that'll become the domain when I do my inverse problem. All right, then state the domain of the new one. So it's by finding the domain and range that you're going to use that helps you find what the domain and range of the inverse that you're going to have. Your homework assignment is a lot more review than it is about this new restriction stuff. There's really not much practice we do with the restriction stuff. There's a review of solving. There's a review of like plugging in, doing compositions like g of f of x. There's some stuff about function and inverses, okay? But the new stuff is on this last page. This is practicing, does it need restrictions? So parabola, yeah it does. Parabola, parabola, parabola. They all need restrictions. You got to figure out what the restrictions are going to be. And very nicely, they put it in vertex form, so you can find the vertex. You can find the vertex. Now this part won't be all that tough. As I originally thought it was going to be. It says use a graphing calculator, but you shouldn't need a graphing calculator for this. Those are going to be pretty basic. Vertexes, the way they have it. Solving here, you're going to need factoring. Get one side set equal to 0 and then factor it. I think you're going to need that here too, because once you square it, you get rid of the square root, and you'll need to be able to factor. Product sum rule, that kind of stuff. Anyway, if you have any questions, obviously rewind and watch. Email Mr. Butterfield, stop in at office hours. But you got the math tutor in B225. You can drop in there and get some help. All right, after you take down all the notes, this is your homework assignment. Do the next class period. See you later.